Hello everybody, we are going to solve equations that have radicals and rational expressions today, and so I'm just going to get started with examples. Okay, the goal is to solve for the variable that makes the statement true. Okay, so what we do first is isolate the radical if it's not already done. That means get the radical part by itself. Once you have that, you're going to raise both sides to the appropriate, and I should say in through there, raise both sides to the appropriate power or exponent to undo the radical and solve. And then sometimes you have to check for extraneous solutions, okay? It won't happen all the time, but I'll let you know when there will be. And that happens whenever you have a variable on both sides. All right, first one, this is an understood square root, right? It's a square root because it's got no index number, so we assume it to be 2. Whenever you have a square root, what you do is you square both sides. Square root cancels with squares, so we just get x plus 1. 5 squared is 25. Then it's just a first grade problem. And we get x equals 24. Second one, we have to isolate the radical, so I'm going to subtract 2 from both sides. Then divide by 5. We get the cube root of x equals 2. This time we had a cube root, so what we're going to do is we are going to cube both sides, so raise to the third power. So we get x equals 8. All right, now we're going to look at the next one here. This one, we have to add 4 to both sides first. And we get the fourth root of 13x minus 1 equals 4. So we're going to undo that fourth root by raising to the power of 4. We get 13x minus 1 equals, now 4 to the fourth, I don't know off the top of my head, so I'm going to do it with the calculator. It's 256. Add 1. We get 13x equals 257. Divide by 13. And I don't know if this will be a whole number or not. Let's see. It is most definitely not. In fact, it doesn't even simplify. Sorry, that's what I was checking. So we'll just say 257 over 13. Okay. All right, next one, add 7 to both sides. And this is 4 radical x squared equals 20. Divide by 4. Square root of x squared equals 5. Now what we need to do is square both sides. That gives us x squared equals 25. Take the square root of both sides, and we get x equals plus or minus 5. Okay? So you just have to be careful with that one. All right, these last two, we have a variable on both sides. So on these, we have to check for extraneous solutions. And when we work these out, they're going to be a little more complicated. So first one, isolated radical already happens. So I'm going to square that side. So we get x plus 2 equals. Now on this side, I have to multiply out x minus 7 times x minus 7. So we get x squared minus 7x minus 7x plus 49, which gives us x squared minus 14x plus 49. And remember, that's still equal to x plus 2. I have to make one side 0 since this is quadratic. We get 0 equals x squared minus 15x minus 51. No, hold on, 47. Okay, and it looks like this one does not factor. I can just tell because the only numbers that multiply to 47 are 1 and 47. So we're going to use the quadratic formula. Okay, so A is 1, B is negative 15, C is 47. Alright, and so then when I continue this out, I'm running out of room here. So what I'll do is kind of go up here and continue. So we get 15 plus or minus square root of, let's just use our calculator here. So we get 37 in the square root. Alright, and then when I look at this, there's no way to finish that answer, so we get 15 plus radical 37 over 2, and 15 minus radical 37 over 2. And both of those are clearly not going to cause my square, well, actually, no, we gotta check those. Hold on. We don't want square roots to be negative, so we know the first one will be fine because that's a positive number. Let's see what 15 minus the square root of 37 is. That gives me a positive number 2. So actually both of these will end up working out okay. Okay. Let's look at the next one. On the next one, the radical is isolated, so we're going to square both sides. Whoops, that's probably hard to tell that I covered up the 1. Oh, it's still covering up the 1. Alright, so we get 2x minus 1, 2x minus 1 equals, those will cancel out, we get 8 minus x. Let's see, 4x squared minus 2x minus 2x plus 1. So 4x squared minus 4x plus 1 equals 8 minus x. I have to zero out this side. So we get 4x squared minus 3x minus 7 equals 0. Let's see, I need to find two numbers that multiply to a times c, so negative 28, but add to negative 3. So that's going to be negative 7 and 4. So we get 4x squared minus 7x plus 4x minus 7 equals 0. We're going to factor by grouping on this one. And I can factor out the x in the first one and a 1 in the second one. So x plus 1, 4x minus 7. The zeros are x equals negative 1 and x equals 7 over 4. Okay, so what we're going to do now is we have to check for extraneous solutions, and it looks like neither one of these will actually cause the variable to be a negative, or not the variable, the square root part to be negative, because 8 minus negative 1 makes positive 9. And 8 minus 7 fourths, well 7 fourths is just like 1 3/4, so 8 minus 1 3/4 is not going to make the square root negative. So those are your two answers for that. Okay? If one of those had made the square root negative, we would not have used it. All right, if you have rational exponents, you're going to isolate the part with the rational exponent, raise both sides to the reciprocal, so flip fraction of the given exponent, and then use your flower power to solve and simplify. Okay, so if I do this with example G, I'm going to add 5 to both sides, and I get x to the 2/3 equals 16. So now this is the part where I go to step 2, raise both sides to the reciprocal of the given thing. So the reciprocal of 2/3 is 3/2. 2/3 times 3/2 makes 1, so it's just x. 16 to the 3/2, that means we have a square root, because remember this is the root, this is the power. So what we're going to have is the square root of 16 to the 3rd power. Square root of 16 is 4, 4 to the 3rd is 64. Okay. On the next one, we're going to add 12 to both sides. So we get 5x to the 4/3 equals 80. Divide by 5. We get x to the 4/3 equals 16. Now we've got to raise both sides to the reciprocal power of 4/3, so it'll be 3/4. 4/3 cancels with 3/4, so we get x equals the 4th root of 16 to the 3rd power. 4th root of 16 is 2, and when we do that to the 3rd power, the answer is 8. Okay. All right, last two. We're going to subtract 6 from both sides here first to isolate the part with the exponent. Negative 48 minus 6 is negative 54. Divide both sides by negative 2, and we get positive 27 equals x to the 3/2. So now what we must do to both sides is raise both sides to the 2/3 power, because that's the reciprocal of 3/2. We want those to cancel out. 27 to the 2/3 means cube root of 27 squared, so that'll be 3 squared, so x is 9. Alright, last one, we need to add 4 to both sides. That gives us 9 equals x minus 26 to the 1/2 power. Alright, so now we've isolated the part that has the 1/2, and this expression is what's being raised to the 1/2. So what we have to do is raise both sides to the power of 2/1, which is just 2. So we get 81 equals x minus 26. Add 26 to both sides, and we get 107 is our value of x. Okay. And so that's how we're going to solve radical equations and equations with rational exponents.